Okay, peeps. Should have wrote physics here for my own reference when I post this. Anyways, hi there. It's 8:30 in the morning. Don't know why you need to know that. There was a question about number 3 from 5.3. I'm going to do that, and then we're going to do lesson 5.4. Oh, I know what I wanted to say. Your due date for physics, the test has passed. But what I wanted to make clear is that, first of all, it's taken me forever to do it, and that's partially due to really poor internet connection. Anytime I click on one attachment, it feels like it takes over a minute for it to show up for me. I don't know if that's the weekend, because I marked a couple tests or assignments each day on the weekend. It's taken forever, so hopefully I'll finish them today. But I do want everybody to know that you can kind of resubmit with I want to say fixings. That's really poor language. Resubmit with maybe fixed work. I just want to be clear about that. I'm giving feedback to everybody. I'm saying, okay, so this question's wrong. This one's not clear. This one needs more detail, etc. And so kids have been asking, well, can I fix it? Yes. I'll let one kind of resubmission happen. And then after that, we'll use kind of the time that we're talking about having built in at the end of the year to kind of fix things. Man, I don't know what's going to happen at the end of the year. But anyways, when I give you your test back, yes, you can make some corrections on it. Okay, just try and get it in within a reasonable amount of time. Like I said, due dates and stuff are pretty flexible. Anyways, let's look at 5.3. So this is number 3, page 241. This is with the roller coaster. So you've got this roller coaster that kind of looks like this. So this is we're just given h for this, and this height, that would be a gross roller coaster, that kink right there. Anyway, this is 16 meters high. All right, so the question says, many roller coasters have loops where carts roll on a track that curves sharply up into the air. At the top, the people are upside down, usually screaming. Little humor from the textbook. For safety reasons, many of the roller coasters must have minimum speed at the top of the loop. In the roller coaster shown in Figure 6, cha-ching, the cart must have a minimum speed of 10 meters, right where that arrow is. Must be 10 meters per second to make it around safely, assuming that the roller coaster starts from rest at the top of the first hill and there's no friction on the roller coaster. What is the minimum height of the first hill? So what is h, basically, is kind of what we're solving for. Well, how in the world do we figure this out? The total energy in the system, this is assuming that it's a closed system and nothing is lost from friction or air resistance or anything like that, is going to be the potential energy at the height of this as well as the kinetic energy. Add those together, that will give you your total energy. So let's start there. So EM equals EK plus EG. EK is 1/2 mv squared. EG is mgh. So this is 0.5. We don't know what mass is. It doesn't say what that is for the cart. And a lot of people, I think, got hung up on that, and that's okay. V16, which I can't remember what that is. That's like 15 is 225, so 16 squared, 294 or something. Anyway, plus m, we still don't know it. 9.8 times the height, which is 16. So what is 16 squared? 256. What did I say? 196? Not even close. 256 times 0.5 is 128. So this is 128 m plus 9.8 times 16 is 156.8. 156.8 m. So plus 284.8. 284.8. So that's all the M joules. So if we knew M, we'd plug that in, but that is the total energy in the system. Well, the total energy in the system has to equal the total energy in the system at any point along the path. So like right here, on your way down, the potential and kinetic have to add up to this, which means it's going to be the same for here. So anywhere along, like as soon as I go here, we've lost potential, but we've gained kinetic, and so on. So if we want M, G, H, and H I'll put like 1 for like, because that's the original spot, equals 280, excuse me, 284.8 M. Whoopsies, wasn't on screen. So MGH1, so we know that we're talking about this part here. This will be the highest point, the first point. And that's also what we want to solve. The total energy there equals the total energy here, equals total energy anywhere else. So we have it at the top of the second loop. So we just got to solve for H. We can cancel M, divide both sides by M. G is 9.8, so H is going to be this divided by 9.8. H1 if you want, equals 284.8 over 9.8. 284.8 divided by 9.8 is 29. And that's with sig figs, right? 2 sig figs. 3 sig figs. 29.1 meters up in the air. Cool. That's the minimum. It could be greater, and then you would lose some energy from friction and air resistance, stuff like that. Anyways, that's number 3, 5.3. Now let's get to the lesson. I'm going to pause it while I get myself organized.